Okay, so we now start and run our application, which we have deployed using Streamlit. So Streamlit run m.py. Hello guys, so this is the dashboard for our Streamlit application that we have deployed locally on our machine. So in this tutorial, we're going to be learning on how to implement the VGG16 model to identify objects in a video. So we're going to implement the VGG16 pre-trained model, which means that we are not going to implement transfer learning to improve on the ways of our pre-trained model. Right. So from our dashboard, we have three panels. The first one is the home. Then the second one is the user upload dashboard, where a user comes and uploads their video that they may want to identify objects from. Then the last one is about the project. So on the about page, we have the names and contact details of the individuals of those we have contributed to this project. Right. So I'm going to explain each and every step of the implementation of the code that we have. I'll also put the link in the description to my GitHub, where you will be able to find and also implement and improve on the code, so you may be able to fork it. It's already done and ready to be implemented. So from our homepage, on the left panel here we have objects that have been identified in the video, that is to my right. So you're able to search for objects in the video, right, or you're able to search for frames that contain the objects that are listed on the left in the video. So for example, you may need or want to play the video while it's playing. You may also search for a DEM, which is mentioned on number 10, and if you click enter, it will return the frame which contains the DEM from the video. We haven't reached this part yet in our video, right? So if you need to go through or browse on the main objects that are in the video, you may search for the frames, right, from the search panel on the objects that are lifted to the left of our video. So if you click enter on an empty string, it will continue to play the video. So as you can see, these are the objects that are being identified by our VGG16 model. And bear in mind that we have reduced the threshold for this video when we were identifying objects to 40%. We are also going to improve or increase the threshold percentage of accuracy when the user, or when we test for the user uploading. Right. So we can see that the model is being able to identify that there's a DEM in the picture, that there is a racer vehicle in the video. A suspension bridge from the video has been identified, a curb, a car mirror, a rule, basically from the instructions that are over on the board, the directions, a banister. So what if a user comes and they have their own video that they also want to identify objects from, right? They will go to the dashboard for uploading the video. In the user upload dashboard, the user is able to upload a different video that they may have, that they may want to identify the objects that are in the video, right? They also have the facility to also search for the objects that will be listed after the video has been regenerated, right? So the first stage is to import the video and upload. So they can either upload or drag the video to the screen or to the dashboard. In this case, I'm going to upload the video for cars. So stage number 1, will be to extract frames, which the process is already been initiated, right? So after the frames have been extracted, we go to stage number 2, which will be to encode only those frames which minimum threshold accuracy we are set to 50%. So for those frames that exceed 50% accuracy on the classification by the model on the objects that are in the frame will only be encoded with the label of the object that they identify. After all the frames have been encoded by the model or have been classified for the objects that they have in their frames, we move to stage number 3, which is to regenerate the frames that have been encoded to rebuild the video that has been uploaded by the user. So stage number 1 of extracting frames has been completed. Now wait, as stage number 2 will be encoding the frames that we have extracted from stage number 1. So we'll pass all the frames right to the model so that the model classifies for us the objects that are in the video if and only if the minimum accuracy obtained on the classification exceeds or equal 50%. So we can check on the progress of the model on the classifications the model is actually performing on. So we can check on the background in the terminal, right? So we can see that from for these frames, right, they have been fully encoded. Frame number 25 is missing here, which means that it didn't meet the minimum threshold, which was 50% on the accuracy, which means that the model failed to identify objects on frame number 25, as well as on the frames that we have the missing numbers for. So frame number 27 and 28, the model failed, or it actually classified the object, but its accuracy was less than 50%. So we'll wait until all the frames that we have extracted have been exposed to the model, that the model has identified the objects in the video or in the frame. We actually have a skip or a jump here from frame number 29 to frame number 67, which means that all the frames that were within frame 30 to frame 66 had a low accuracy that couldn't meet the minimum threshold of accuracy, which we have set to 50%. So we have finished encoding the frames. We get to the next and final stage, which is building or rebuilding the video with the frames that have been encoded, and we have finished those stages as well. After rebuilding the frames, after completing all the 3 stages, extracting frames, encoding the frames, and rebuilding the frames, we have a video which when we play, we have the objects that have been identified. So unlike in the first video, you can see that in this video we have spaces or gaps between the time of recognizing objects or detecting objects, which means that for the empty frames the model was predicting the objects with the threshold of less than 50% accuracy. So we now only have accuracy for the frames which have objects with an accuracy greater than 50%. So hence, this is how a user can upload their video, right, and determine the objects that are in the video using the VGG16 model. So for those interested in implementing the algorithm and improving on the code that I have used, I'm going to put the link in the description below so that you may be able to access the code from my GitHub.